Okay, we continue on how to use ashing to destroy a very hard samples such as rock and also other biological materials that is hard enough, such as bones and so on. So you can use dry ashing. So ashing in electrical chemistry is where you heat a substance at high temperature, be it with acid or without acid, and you have to use a furnace. So what is a furnace? Furnace is somehow like an oven, but it can produce high temperature starting from 500 degrees C up to 1000 degrees C. Okay, so this is how the furnace looks like. Okay, it is really small, but you see that the thickness of this area is high to maintain high temperature. Why high temperature? Because we want to destroy the matrix, the materials. Okay, in this case, skull is made out of a lot of calcium and so on, and agricultural materials, minerals, they are hard to be digested by using normal wet digestion. Can also be used for organic polymer and also petroleum products. And it's usually using temperature between this and can be up to 1000 degrees C. Okay, in order for you to use this kind of temperature, you have to put a container that can withstand that temperature. Therefore, usually it's porcelain or platinum. Porcelain can withstand around 550, but platinum can withstand around 1200, but it's platinum, therefore it's expensive. Okay, can also use nickel and iron, but not at this kind of temperature. Okay, and magnesium nitrate is usually used as ashing aid. Okay, so that it can combust the matrix even more. And then we have without any acid, we are doing dry ashing. And if you add any acid, you are doing wet ashing. Okay, wet ashing. Okay, be it when you add sulfuric acid to prevent volatilization, or you can also add the acid that I mentioned just now in wet digestion, nitric acid. You can also use strong acids such as hydrochloric acid and so on. Okay, you can do low temperature ashing if you are using activated single state oxygen, and also we have closed system ashing, whereby your ashing can be done in Schrödinger flask or an oxygen power bomb, whereby it can it's like a pressure cooker in the furnace, but it's risky lah. Okay, the advantage of ashing is that it is able to decompose hard matrices and at large size of sample, little or no reagent, because we only use, if we are using wet ashing, you are using only few mils of acid. Relatively safe. Okay, and here related with this size of this one. Okay, but we have to take care of the contamination from the container itself. Okay, the muffle itself, we have to take care of that. And also we can lose certain analyte due to volatilization. So you have to understand, if let's say you want to ash silica matrix containing iron inside it, so you have to think about at what temperature iron can stand. Okay, you want to destroy the silica matrix, but you want to retain the iron, so that's the dilemma over there. So in order to do that, you have to take care of the volatilization. Okay, and then we have a fusion technique. Fusion technique is a very old technique that use inorganic flux. So what is flux? You can have a look inside books and sign directs about flux. Basically, flux is the combination of salt. Okay, salt can also use alkaline condition, and some of it use different kind of alkaline condition, can also use disodium carbonate. Okay, the temperature is given over here usually if you want to do certain application. If let's say dry ashing doesn't do the work for your silica, you can use fusion technique using disodium carbonate at 1000 degrees C to destroy silica. Okay, this is more towards last resort, because flux is very expensive. It need actually very sophisticated instrument. Okay, I'm not sure whether I have the video here. I try, but if I don't have the video, we can always go to YouTube and find flux. Okay, and also they are labor intensive because we have to wait for it. Okay, let me see if I have the video. Cannot open. Okay, I don't have the video, but never mind, you can find in YouTube. It is you can find how to prepare solution by fusion for AA and ICP analysis. Okay, this is an example of lithium carbonate fusion. You can read in on your own. Okay, I'm going to stop this video so that we can give way to class activity. Okay. Okay, how many people we have in our class? Okay, so make a group of two people in a group. I will give you two kind of journal article. One is on microwave digestion, and this one is acid digestion. So look at their experimental. Okay. Okay, you can. I will give you the link for Padlet. Okay, Padlet is where you can write whatever you extract from this paper inside the website, and everyone can see the information. So you are actually doing like cooperative learning. Means that you write your information, you everyone see it, and everyone can save as notes. Okay, on the experimental, and then the result and discussion. Okay.